Welcome back to another flipped math lesson with Mr. Valleau, and today we're going to be looking at multiplying polynomials. If you recall from our last lesson, polynomials are multiple monomials or multiple individual terms with variables. So last time we talked about adding and subtracting polynomials. Well, today we're going to be looking at multiplying polynomials. And we have three different methods that we can use for multiplying polynomials. So let's take a look at the first one, which is the distributive property. Now, the distributive property you're used to is an example, just to give you an example, is let's say you have 3 times a parenthetical x plus 2. And you're used to using the distributive property to divide that out into 3x plus 3 times 2. And that's the same rule that we're going to apply for multiplying polynomials with the distributive property. So the first thing you're going to do is we're going to break apart this first polynomial and we're going to distribute it into this second one. So you're going to start out, you have x as the first term in the leading polynomial, and we're going to multiply that by x plus 2. So we're going to break it down into the same distributive property that you're used to seeing. And then we're going to multiply that whole piece by 8 times x plus 2 in the second. So what you end up with then, as we use our distributive property, is you end up with x squared plus 2x. And that's the result of the first distributive property. And then you've got 8x and from there we have 8x and 16. And now we combine our like terms until we end up with our result of x squared plus 10x plus 16. And we can't combine this anymore. We make sure that we have our highest degree monomial in the front with the x squared, and there is no leading coefficient, so we have successfully multiplied this polynomial. And we've used the distributive property. Now, the next method we're going to look at is the table method. And this one is very much the same. What we're going to do is we're going to divide out these terms, and we're going to create a table. So just to give you an idea, we're going to make a table here of our different values. And we're going to begin to put them all together. So what we have then is we have the first term up here, 2x and 3. And on the other side, we have x and negative 3. So now we've divided our terms out into a table, and we can then multiply and find those products as we go through. So 2x times 2 is 2x squared. X times 3 is 3x. And then on the bottom, we have 2x times negative 3, which is negative 6x. And negative 3 times 3, which gives us negative 9. Now, from here, we have to make sure that we put our product together appropriately. So again, we have to look at our highest degree monomial, which is the x squared. So we lead with 2x squared. Then our second highest degree is going to be just the x's. So we have 3x, a positive 3x, and a negative 6x. And then our 0 degree monomial is 9. And from there, we're able to combine like terms until we end with 2x squared minus 3x minus 9. And again, we have multiplied our polynomial, and this time we have used a table method. And the final method we're going to take a look at is the FOIL method. Now, this is very much like the distributive property, and we just talk about it a little bit differently, and it allows us to work, in some cases, quicker through our multiplication of polynomials. So the FOIL method says that we multiply using FOIL, or in this case, the first terms, the outer terms, the inner terms, and the last terms. So essentially, we're going to multiply the first terms together. Then we're going to multiply the outer terms together. And if you notice, what we've done is we've distributed the x from the first polynomial into the second. So we've multiplied the first set of terms, first term in the grouping into the second. So we've done the first and the outer, then we do the inner terms together, and finally the last terms. And when we multiply those together, we find that we have x times x, which is x squared. We have x times -7, which results in -7x. Then we go to the inner terms, where we have 3 times x, or plus 3x. And finally, 3 times a -7, which leaves us with -21. And in this case, then, when we go to combine like terms, we end up with x squared minus 4x minus 21. Now, the last thing we're going to go over is how we multiply binomials and trinomials. Now, if you'll notice, previous to this, we've done just binomials, putting them together. Well, now we've got a trinomial we need to deal with. And we can use the exact same method. And what you have to do is, anytime you remove a term to multiply it from this first grouping, you have to multiply it by each term in the second grouping. So if we start off, we know that we're going to have x times x squared. So really what we end up with is x cubed. And then we're going to multiply x by -4x, which would result in -4x squared. And then finally, by the last term, where we end up with -4x. So that takes care of that first grouping. And then we have to deal with the -3. So -3 times x squared is -3x squared. -3 times -4x results in positive 12x. And -3 times -4 results in 12. And now it becomes a little more complicated, but now we just combine our like terms, and we lead with our highest degree of monomial, which is x cubed. Then we're going to combine our x squareds, and that's going to result in -7x squared. We're going to combine our x variables, so -4x plus 12 is going to result in 8x. And our constant is 12. And now we've combined all of the like terms, and we have multiplied a binomial and a trinomial.